In this video, we are going to see about the image segmentation. And image segmentation is a process of partitioning an image or data set into a distinct, meaningful region or segments. Each represents different objects, structure, or features. It is used to isolate and analyze specific part of an image to facilitate tasks such as object recognition, classification, and measurement. Segmentation can be categorized into several types, each suited for specific applications and data types. Semantic segmentation, instance segmentation, panoptic segmentation, edge-based segmentation, region-based segmentation, threshold-based segmentation, cluster-based segmentation, supervised and unsupervised segmentations. Semantic segmentation. All pixels belong to the same class or objects are assigned the same class. So it has a key characteristics, that is picture level labeling, class level grouping, high level context. So the methods and architecture in which these semantic segmentations are applied are UNet and FCN Deep Lab. So the applications where it can be applied: medical imaging, autonomous driving, satellite imaging, agricultural imaging. So its limitations: if the application need individual instance differentiation, so where we need to go for the instance segmentation. So instance segmentation, where each individual instance of the object is segmented and labeled separately, even if multiple instances belong to the same class. So the key characteristics are picture level classification and differentiation, instance level identification, object detection, and semantic segmentation. So the architecture in which it is used are mask or CNN. You only look at coefficient, tensor masks. Applications where it can be used: medical imaging, robotics, augmented reality. So its limitations are it's computationally intensive due to the dual task of object detection and picture level segmentation. It requires detailed annotation. Um, Panoptic segmentation, it combines semantics and instance segmentation, labeling each pixel with a class label and also distinguishing different instances of each class. So its key characteristics are unified segmentation, single output for both background and foreground, detailed scene understanding, and methods and architecture in which these segmentations used are: feature pyramid network, efficient PS, unified panoptic segmentation network. So the applications are autonomous driving, robotics, augmented reality. So it has a limitation. It is computationally intensive. Training require excessive unacted data set. Edge-based segmentation, the uses edge detection algorithm to identify object boundaries by detecting changes in intensity and color. And its key characteristics are boundary focus, gradient-based detection. So there are number of types of edge detectors are there. So first one is oval edge detector, canny edge detector, rivet edge detector, Laplacian or Gaussian. So the application where it can be used are medical imaging, object detection, facial recognition, optical character recognitions. So it has also limitations. So when we use with the image where edges are unclear or disrupted by noises, shadow, or difficulty in images with structured regions, then it may fail to provide a complete segmentation if the region themselves are not adequately separated by distinct edges. Region-based segmentation, it divides an image into region based on the criteria like similarity in color, intensity or structure. So the key characteristics are region homogeneity and connected region, and the type of region-based segmentations are region going, region splitting and merging, watershed segmentations. So the application where it can be applied are medical imaging, object recognition, satellite imaging. So its limitations are it struggles when region lack homogeneity or have sufficient overlap in intensity between different areas. Next, threshold-based segmentation. It applies a threshold to classify pixels based on their intensity values, typically separating foreground from background. So the key characteristics are intensity-based and finite segmentations. So the type of thresholdings are global, adaptive, and also. So the application where threshold-based segmentations are used are medical imaging and document scanning, industrial inspections. So the limitations that face this threshold-based segmentations are less effective on complex images with varying intensities of structures, and struggles with low contrast images, noisy images, and so on. Cluster-based segmentation, it uses clustering algorithms like K-means to group pixels based on features like color, intensity, or spatial locations. So the key characteristics are feature similarity, supervised or unsupervised learning. Um, the types of clusterings that that are available are K-means clustering, mean shift clustering, Gaussian mixture model, and spatial clustering. So applications can be medical imaging, remote sensing, image compression, and the limitations are it's sensitive to initialization and noise, struggles with the images that have variations with the regions. Next, the unsupervised and supervised segmentation. Supervised segmentation involves training a model with labeled data. Unsupervised segmentation, it requires no labeled data. Here is the summarization of and differentiating the supervised and supervised segmentations, where supervised segmentation requires labeled data and the model applied are deep learning model, where CNN and advanced architecture like UNet are used, and it is applied for the medical imaging, autonomous driving, and satellite imaging, and it is it has ability data intensive, and it is domain specific, whereas the unsupervised algorithm it needs no labeled data, so it uses clustering, edge detection, and region cloning algorithms which can segment based on pixel similarity. It also adopts the inherent pattern in each image, making it suitable for explanatory analysis. So it is applied in explanatory data analysis, medical imaging, and environmental monitoring. So it has low accuracy and lack of semantic information. This is a limitation due to exercise. And to conclude, the segmentation is crucial for transforming images into actionable information while evolving techniques enabling higher accuracy and real-time analysis. As technology advances, segmentation continues to enhance capabilities in various applications, from precise medical diagnosis to autonomous navigation. Thank you.